Hey everyone, I'm Nick, and I lead engineering at Cross Protocol. So today, I didn't want to talk about why intents are the best architecture. I think people from my team have given this talk a lot. You might have seen Hart's talk. So I came up with a new talk where I'm going to dive into a couple new ideas by way of going through what I think are two pretty hard problems in blockchain interop, and we'll explore some of my new ideas. So I call this talk The Last Mile and the Stamp. So I'll first define the blockchain interop problem. So this is the problem of a user having an asset on one chain, wanting to do an action on another chain, but needing to pay with that asset to do that action. This is the core problem we at Cross and many people in the chain abstraction space are trying to solve. So the hard problem number one is that the rollup-centric blockchain topology, which is kind of how Ethereum has played out so far, and I'll give a lot of visuals, will not allow for a universal interoperability solution. This is something we found from experience, and then I'm going to pitch or predict what I think is going to play out, just based on how the topology of the network has played out so far. So in 3 slides, this is how blockchains have evolved. In the beginning, there was a hub nation, Ethereum. And then there were subnations that branched off of the hub. And now we're at a point in time where each of these subnations wants to create their own federation where they themselves become the hubs. And I think we're going to keep seeing this pattern. I kind of visualize it as a pyramid, and it's going to keep fractaling down. And the hub chains like Arbitrum, Optimism, that are creating their own like OP-Stack, Orbit chains, they're going to be relatively few compared to the spokes. And the ratio of spokes to hubs should keep increasing if this follows any natural process. So we have problems where we have liquidity and user attention fragmentation as a result of this topology. And we've come up with some solutions to bridging this fragmentation, and the solutions are not quite there. So today, all of those lines connecting the spokes and the hubs are canonical message bridges, and they're pretty slow, and that's kind of why I do what I do at Cross and why a whole ecosystem of bridges has spun up that are offering faster bridging. L1 to L2 usually takes 10 minutes. L2 to L3 is going to take about the same time. These are rough estimates, but we're talking on the order of minutes, not seconds. L2 to L1 and L3 to L2, so traversing down the pyramid is going to be slow. And this is kind of natural with how these rollups are architected. So third-party fast bridges have naturally developed on top of this topology. You can imagine fast bridges as a layer, almost like a mesh built on top of these canonical bridges. They generally provide arenas for solvers to offer faster bridging in exchange for underwriting finality risk and taking in fees. I think that's a pretty general definition of any bridge. But every day, we see that there are new L2 and L3s who want day one bridging support. And every day, users get frustrated that they can't get to these chains fast enough. They're not satisfied with the canonical message bridge, or they don't want to call the contracts, and someone is not offering this solution. And the bridges can't keep up. So how can fast bridges keep up with this demand for their services? I don't think it's possible. I don't think it's possible for a single bridge system to be able to service all of these new nodes while maintaining their current level of service. And I think it's an engineering problem, as well as one of the properties of decentralization, where adding a new node to a bridging network, keyword network, will increase operational burden or security assumptions for the bridging network. There's kind of no way to approach this without moving along the spectrum of decentralization towards centralization, or just increasing your team and trying to manage this very hard engineering problem. And I think a more natural solution is we're gonna see bridge to architecture bifurcate. So I think there will be one bridge network, and I'm gonna show some pictures to illustrate this. There's gonna be one bridge network that will connect all of the core L2. So imagine Arbitrum, Optimism, Polygon, where all the liquidity is today, and there's gonna be a few winners in this space that are able to connect all of these hub L2s. I think that there's going to be another bridge network that rises up in parallel. I'm going to call it, this is the last mile bridge network. This is getting from L2 to L3. This is leaving the core L2 network to these random L3s. No offense, but the TVL is going to be a lot lower than these bigger hub chains is what I predict. And some sort of distribution solution that will solve the interoperability UX problem is going to somehow seamlessly stitch together these transfer requests from between the hub network and to the last network. And I think there are a lot of analogies with how mail is sent out today, how it stitches together, like going from a car to a bike to the last mile problem. And I think all of this is eventually going to be abstracted away from the user, but I largely predict there's going to be two parallel systems being built. We're already seeing solutions to the first core bridging problem today, where there are fast bridges like across Stargate that do service the L2 to L2, but they can't keep up with the new L3s. So I think what I would do, if I'm putting on my prediction hat, is I would start building a solution to this last mile problem. So what is that going to look like? So imagine we're in the OP stack right now, and we've got unit chain, world chain, mode, Lisk, all these OP stack chains, and they're popping up new every day. L3 to L2 native interop is not live yet, but eventually the connections between the L3 and L2 are going to be relatively fast, on the order of minutes. But users are still going to demand faster. They're going to be willing to pay some trivial fee for a faster bridging solution. And this is what I think this last mile bridging network is going to look like. And it might not even be a network. It might just be something that is, sorry, I'll go back to that slide. This last mile bridging network might just be a permissionlessly deployable system. It might just be a point-to-point system that's easily deployed by the app chains whenever they want to roll their own bridging solution. And this should just, I think this is something that we're thinking about. This is something we've talked with folks about building, and it's going to be built on top of some sort of third-party fast messaging network. It's going to be easily reused, easily deployed, very simple, very lightweight, and most importantly, it's going to be composable with the core L2 to L2 highway bridging network. So I think the full network is going to look like this. There's going to be a green core network, the highway, where most, like 90% of volume is going to go through in the bridging space. And then the last mile is also going to, that's ultimately where users are going to want to get to. But there's going to be some SDK or front end that is going to abstract away all of these hops and just make it feel very seamless. And the winning solutions will be a very fast highway and a very fast last mile network. So now this leads very naturally into the hard problem number 2, where we're going to talk a little bit about user experience, where there should be a common language for expressing cross-chain transfers. So consider sending snail mail. This is, if you think about it, we all know how to write a letter. Like, you know how to address a letter. And it's pretty mind-blowing that you can write a letter the same way to get to New Jersey as you can to get to Shanghai, right? Like, you can send a letter anywhere in the world with the exact same format. And that's something that we can do in the blockchain space. That's exactly what we're trying to do when we're trying to standardize cross-chain orders. So consider the journey it takes to get from New York to New Jersey versus New York to Shanghai, right? Magically, the same mail addressing format plus a stamp gets the mail on a boat, on a plane, on a truck, to the last mile. Like, this is all abstracted away from the user, and they somehow get their mail, like, wherever they are. And I think this is a really crazy solution that we've come up with. Interestingly, the last mile problem is always solved by local delivery people who understand the local area well. And I kind of view these local delivery people, they're going to look like solvers. So relayers and not users, relayers, solvers, fillers, same thing, should understand how to solve the message transfer problem, including all the various hops that the message needs to go through. But users shouldn't have to care about this. This much is obvious. I think we were all on the same page about this. A bridge should abstract away that journey from the user. And the first step to solving this problem is improving the user interface. So specifically, I think there should be a common language for users to express cross-chain transfer intentions. So this is the current state of the situation today is a user wants to send a message to some destination chain. They need to know how to use the specific bridge they want to talk to. So a common interface is simply just making sure that the user is speaking with a single interface, and then it somehow routes to the correct bridge that they need to get to. Now, the second part of the problem is also very hard, which is that solvers who interact with each of these bridges, who ultimately send the mail to the destination chain user, they have to understand how to use the different bridges. But solvers are more sophisticated actors than users. They can figure this out. They get paid to do this. And ultimately, we do want to make solver UX good as well, but it's less important. It's less urgent. It's more urgent that the user today is able to just access the network with a single addressing interface. So much like the last mile delivery man, it's the solver's responsibility to figure out which bridge they want to use to settle the order fulfillment. Now, I think there's a lot of counters. By the way, I'm an author of ERC 7683. That's kind of what I was talking about. I think that's one solution to this cross-chain order interface. And one of the major counterpoints against it is that it's bridge protocol agnostic. It's not opinionated about how the cross-chain order should be fulfilled. And that would drastically improve solver UX, but I just don't think that that's very important right now. I think it's more important that we agree on a standard way to express your intent. And then we'll figure out the solver UX later, and 7683 can easily plug into some sort of, some other interface for standardizing bridge settlement. So it's a feature that relayers need to perform work to figure out how to fulfill an intention because they're incentivized by profit. Relayers are sophisticated actors. They're willing to get paid. And the analogy here is that companies choose which delivery service is best for their delivery needs. For example, FedEx, UPS, DHL, depending on where you're trying to send the message, they offer a different feature set. And ultimately, it's up to companies and not users to figure out which delivery service they want to use. So similarly, different cross-chain message networks offer very different trade-offs. Hyperlane versus Layer 0, they offer a different set of sacrifices for users to take on. And this should ultimately be decided by the DApp and the solver. So I think eventually all of the bridges or all of the solvers will be able to also communicate with a single interface. But I think that's a follow-up. I guess this is kind of a hot take, but I think this is a follow-up ERC or EIP that needs to be written. So I'll end with what I think is an ideal cross-chain transfer flow. A user expresses a cross-chain intention to the DApp. The DApp forms that intent into an order, sends it back to the user. The user signs it, returns it back to the DApp. And these back and forth things are OK because it's all happening on the front end. And then the DApp sends the order onto the best settlement network for their use case. So FedEx, USPS, UPS, DHL, et cetera. And so I think it's actually not a good thing if we're too prescriptive about how a bridge should look or how settlement should look, because that might hinder the first goal, which is creating a universal cross-chain order interface. And so I think it's of the utmost priority in order for us to solve this interop problem to solve the mail addressing problem. And that's it. Thank you.